from your Algebra 1 days. And so I'm just going to jump right in, and I'll explain a little bit more. In Algebra 2, we dive in a little deeper with regards to transformation and modeling. In the real world, the way that we use math is that we collect data. The data looks like a shape, and then we write a function that kind of models that shape, and it helps us to make mathematical predictions. So in example number 1, we're asked to graph the following function. F of x is equal to 1/2 x squared, right? And we could think of that as f of x, the function of x, is equal to ax squared. And this is the basic graph function. Actually, the parent function is y equals x squared. And so y equals x squared, as you guys remember, is just going to be like a little parabola. So let's write that down over here. Y equals x squared. It's just kind of like one of these things where you have like the little parabola that comes through the origin, and it looks like that. We call it the conic section. I'm going to throw that term around a lot. If you take a cone and you slice the cone a certain way, this would be like an upside down cone, but if you slice through the cone, you'll get a parabola. All right? So this is also a conic section, but we'll talk about that a little later. And so there's a couple of things that I want to point out to you guys. One is that where the minimum or maximum value is, we call that the vertex. All right? And then the vertex always goes through what we call a line of symmetry. And so the line of symmetry just means that the left-hand side of that line is going to be identical to the right-hand side of that line, and it always goes through the vertex. Okay? Now in the parent function, the vertex is always 0, 0, and the line of symmetry is x equals 0. So on this parent function, y equals x squared, the vertex is always going to be the origin. Oops, ran out of room. And then the line of symmetry is x equals 0. And so when we transform the functions to make it fit models or data, we're going to take that graph, we shrink it or stretch it, move it up or down, left or right. Okay? So we're going to start with the first basic thing, and that is going to be this, what we call a constant multiplier, or the coefficient of x squared. Now the coefficient of x squared will either stretch it vertically or shrink it vertically, but when you do that, it makes it look like you're stretching it horizontally or shrinking it horizontally. In fact, some textbooks refer to it as shrinking and stretching horizontally, and they have rules that apply. Other textbooks will say that you're shrinking and stretching it vertically. It just changes the shape of the graph. If A is negative, then it flips it. So let's write a few things. A, it will either compress it or it will expand it. And if A is less than 0, in other words, it's negative, it flips it. Okay, so what I'm going to do in all these cases, until you're pretty familiar with it, what we're going to do is we're going to just graph this real quick. So I'm going to go ahead and grab your graphing calculators, and we're just going to go into y equals, and I'm just going to plug in 1 divided by 2 times x raised to the 2, and just graph it. Oh, I probably got to adjust my window to standard.
Oh, look at that, I'm learning.
Okay, fine. But yeah, that's it right there. Okay? That's what it looks like. Now, how does that look different than the original one? Well, let's go and plug in the parent function. If I plug in the parent function, I'm just going to get x squared, and that's going to be red. So red is the parent function, and blue is the transform function. So by changing A to 1/2, what we end up doing is we compress it vertically. And when we compress it vertically, it makes it seem like we're stretching it horizontally, right? Does that make sense? Okay. And so what that would mean is that maybe Mr. Adams, when he does some research, I get like these little data points, right, that are a little bit outside of the regular parent function, y equals x squared. And so I'm going to manipulate that number in front of the x squared to make it stretch or shrink to fit my data. Okay? And it's just like linear regression, but we would call it a quadratic regression. I'm kind of teaching ahead, but that's really what we're trying to do. Well, what is, I forgot, there were a couple of questions they asked us. Oops, I didn't want to do that. What is the origin of our function? So let me turn this off so we can just look at our function. What is the origin of our function?
0.
I meant to say vertex.
0.
The vertex is 0, 0. It's the origin, right? And then what's the line of symmetry?
X equals 0.
X equals 0. So what we're going to do is say for this function, we would say that the vertex for this function is going to be 0, 0. This x value is always x equals 0, or that's the line of symmetry. Okay? Any questions on that? All right, so we know what A does. Now, just so you guys kind of know, I'm going to come in here, and we're just going to play around with this. What I want to do is I want to insert a negative value in the front. Now, when I put that negative value in front, what will it do to my graph? It will flip it about the x-axis. So now when I hit graph, watch this. Boom, flipped it. Because what that's doing is our y value is dependent on our x value. Okay? But whatever my y value was before, I'm multiplying it by a negative. So before, when I had a positive 3, by me putting that little negative sign in the front, it now becomes a negative 3. In other words, and let me show you, because I'm going to come in here, and I'm going to say 1/2 divided by, or 1 divided by 2 times x raised to the 2. So they're both the same functions, but one has a negative sign in the front. And so if we look at the table of values, what you can see is that my y values go from being negative values to positive values. And that's where we get that flip from. Does that make sense?
Yep.
All right.
From positive to negative.
Yep. And if it were to be a negative value, it would have been flipped to, but we don't normally do that because we square whatever the x value is. All right, so let's move on to example number 2.